Welcome back to Further Solutions Academy. Further Solutions Academy. Make sure you share and subscribe to others. And comment also is very important so that we know how our videos are going. You can comment below to update or to get us involved in any of the problem, or you reach us with +234 80344 95990. Now with this line you can call us, you can WhatsApp us, and also Telegram is allowed. Either of the three, you can reach us on this. Now on this video I'll be working on definition of topology. Definition of topology. The outline of this video, the first one is definition of topology. The second one is definition of topological space, and third one is examples, which example will contain some proving, how do I prove on topology, what are the things that you need to consider. Now let me start with definition of topology, which is the first outline. Now when we talk about topology, how do I define topology? Topology, normally anytime you define topology, you must to consider four things. The four things. Now, but normally I will first declare something. There will be a declaration. Declaration will let us let x be non-empty set. And I'll also say and. Normally, some of my lecturers, some of my people, they use the word tau. I call it tau. Now, this is how we write the tau. Tau, it means I'm talking about topology itself. That is what I mean. Tau. Let me use tau because so that we're going to be familiar with it. Tau is family of subset of x. Tau is said to be topology. Unless if it satisfies following conditions. Now, these conditions are so important when you are asked to define topology. All what I'm saying here, they are just expression, but the definition, this following conditions is very important. And anytime you are asked to prove anything on topology, you must work towards that. What I'm about to those conditions. There are four of them. The first one is number one, empty set, which I've explained that. I've told you that topology is all about geometry. We are flipping, we are deforming, we are stretching. I've told you, but in advanced part of it, we'll be relating it to what? To sets. That is why in my previous video, I've explained concept of set and the denotation, because at this point we write less English and you use much symbol. Take note of that. Very important. Now, belong to tau. Now, in topology, I will not write this English. This is how I will write empty, belong to tau. That is how to write it in the normal sense of topology. Now, this English, just like I'm just blowing English. This is the most important things at this junction. Now, number two. Set X belong to tau also. It means, what am I trying to say? My X belong to tau. Very, very important. Now, let me quickly explain these two before I go to the last two. Now, what I'm trying to say is that if I have a shape like this is a set. I call this place a tau, and I have my heads can be, these are the sets, these are the sets, these are the sets, these are the sets. Now, on this set, number one, there are empty things. These are the empty parts. These are empties. These are empty. These are empty. Number two, and there are what? S in that tau. There are S in that T, which is S. What? X belongs to what? T. S belongs to. It means interpretation of set. I'm saying that what? S is a subset of T. S is a subset of T. Can you see how important set to topology? That is why I have to start the class. And the third one, you have to explain for every union of member of tau is again member of tau. Now, in the normal sense of it, it means what I'm trying to say here is that in terms of set notion, I'm talking about the universal of a given set. The universal set is a what? Is a member. For instance, if I have the universal of a given set is also what? Is also belongs to what? Belongs to tau. That is what I mean there, which is the third one. The last part of it, every intercept of a member of tau is again member of what? Of tau. That is what I mean there. It means number 4, every intersection of member of tau is again member of tau. It means the third one is universal, union, and the third last one is what? Which is the third, fourth one is intercept. Is intercept. Now, before I continue, let me show example. Now, don't forget that anything you are asked to do on topology is mostly you have to prove, and your proving it will be related to what? Those three conditions. Those 4 conditions I just listed now. The first one, empty belongs to what? Tau. The second one, the given set belongs to what? Tau. And the third one, the union of the given set is also the member of what? Tau. And the last one, the intercept of the given set, also a member of what? Tau. Take note of those things. They are so important. Anything you have to do in topology, mostly you consider those 4 things, those 4 conditions. Now, look at this problem. Let me quickly give a problem to explain that. Okay. For example, x equals to a, b, c. This is how question will come. Tau, which is tau can be let me just have empty set A and x in self. Don't forget x is a set in itself. Now that is what I'm going to do. Prove that is a topology. This is a very simple example, just to give to enlighten or to back up my conditions that I listed earlier. Now, if I'm to do this, the first thing I will try to explain is that empty That is number one. Empty belongs to what? Tau. Very correct. Number two, X belongs to tau. It means first and second are satisfied. Now, those ones are satisfied. Now, I'll move on to the next one. Those first two are satisfied, which no problem. Can you see that empty is an element is in inside of what? Tau, and set himself, which is this set, is also inside of what? Tau. Now, I will move on to the next one, the third one now. Now, the third one. Now, anything that intercepts empty set is empty. Now, look at what I'm trying to explain here. If I have empty intercept set A, will be equals to what? Empty set. Take note of that. And if I have A, set A, intercept X himself, it will be equals to ABC. BC. To be equals to BC. Now, it will be equals to BC. Okay. Okay, am I saying something? Yes. It's equals to BC. Now, it means they are all belongs to what? Tau. They are all belongs to tau. Since they are belongs to tau, it means it is satisfied. Its third is satisfied. Now, the last one now, the last part of it, which is the fourth one. The fourth one will be, okay, the fourth one, I'm talking about what? Intercept. The intercept part of it, it means, okay, this is, the third one will be the union part of it. Now, the union, of empty set with another set is the set. Now, what that means there is that if I have set union A will be equals to what? Set A. Now, can you see that also if I have empty union set A union X, and can you see it will be equals to okay, this is also that. Now equals to what? X himself, which X is a member of what? Of tau. That is what I mean. It means fourth is satisfied. Now, that is all about it. Now, by so doing that, I've proved that the question is what? Is topology. Now, before I end this video, let me move on to the next outline, which is definition of topology space, topological space. Now, before definition of topological space. Now, this time around, what are topological space? Before we call something a topological space, you must understand some things. Then, X and tau is called topological space. S is non. You must know that S is non-empty set. Now, tau is family of subset of X. Tau, which is a tau, sorry, this is how we write our tau. Tau is topology. Tau is topology. On X, tau is topology. Now, condition also, the conditions, number one. Look at the condition, number one. Empty belongs to what? Tau. Take note of that. Empty belongs to tau. Number two, X belongs to tau. That is number three. Number three, any union of member of tau is a member of tau also. Now, what I'm trying to say is that I belongs to the index, which is, and the subset of T, which is tau. U of A index is an element of what? Tau. That is what I'm trying to say there. Okay, the fourth one, finite interception, okay, of member of tau is a member of tau, which is I'm talking about A1, A2, and so on to what? AN, a member of what? Of tau. Now, in a way, I will write intersection I to a member of this, which is of A index, is an element of what? Of tau. That is all about that. Now, if I have those four things satisfied, it means X tau is called topology. Topology space. Topological space. Okay, now please let me quickly explain with this all what I've explained with the structure. Now, if I have this is a set, I call it the tau himself, and S inside tau. These are the. Now, number one, can you see that all what I've explained here are here? You can see empty. These are empty one, and these are intercept, and also the union also exists. That is what I'm trying to say. Now, let me quickly back it up with example so that you will really understand all what I'm saying. Because don't forget, anything you do on topology is about proving for those topological space. You prove for 4 things, and normal topology you also prove for 4 things. Don't forget, empty is an element of topology. That is the very first one. Second, the given set is also an element of what? Of the topology. Third one, the universal set is one of the sets, also belongs to what? Topology. And the third one is what? Intercept, finite intercept. Don't forget those things. Now, example. Let's talk about example now. Example. Now let x equals to a, b, c. Now, and okay, now don't forget everything. Mostly what we are going to do in Prof is that we prove or we show. Take note of that, and those things you have to show, they are those 4 conditions. Now tau equals to I have a comma, I have b comma, I have ab, and x in self, and what else? And the empty. There must be empty also. Now there must be empty. B collection, B the collection of subset of x. Then show that tau is topology on x. Can you see the question land us to show or prove? Those things, they are so common to topology. At this point of mathematics, no solving. You show or you prove, either of the two. Now, if I'm to show this solution to this problem, what I need to do, the first one, empty, that is the first one, belongs to what? Tau. Very, very important. That is, you can see empty is inside tau. And also, x, that is number 2, belongs to what? Tau. Which is this x belongs to tau. Now, it means first and second are satisfied. Now, that is very good. The next one, which is going to be third one, I've been using counting. Let me use the third one. Note that A union B equals to AB, comma, and A junior ABC are also equals to ABC. Okay, since all these are this, it means, since they are in it, it means A junior B equals to AB are all inside. But all what you do here, they are all inside of tau. They are all inside of what? Tau. It means third is satisfied. Third is satisfied. Now the last one, which is the third one, the fourth one, we have to show is that A intersection B is empty. A intersection B, which is set A intersection set B, is empty. Also, and A intersection set AB is A. Can you see? Empty is inside topology. The set A is inside topology, and which again, I think with these two you can generate your. It means they are all a member of tau. They are all the member of what? Of tau. It means fourth is satisfied. That is all about that. That is all about it. Now, since it's satisfied, it means tau is topology. Topology on X. Tau and X is topological space. Topological space. That is all what I mean. Can you see? That is all what we are going to be doing related to what topology. I will be stopping here, and if possible, the next video will be proving a lot of questions. We'll play with questions and answer on topology. Once again, with this, you can see that how topology, the structure of topology, how it looks like. Once again, thanks for watching.